section we're looking at methods of solving a differential equation using a definite integral. Now this is a really useful method to use when an indefinite integral doesn't actually solve your differential equation, and that can be just because the function that you're looking at is a little bit too complicated and your CAS isn't able to solve it indefinitely. So what we're going to look at here is just a general example. We've got dy dx equals a function of x. Let's say that we theoretically integrate both sides of this. So we may not be able to actually integrate little f, but we'll just call it big F when it's integrated. So if we integrate both sides, we're going to have a y on the left side equals our function of x plus, we'll call it c. And this is where our integral of f of x, a little f of x, equals big F of x. So we've got this step here. Now what we want to do is look at the conditions that we have, and this is the general case of where we have our differential equation given, so we've used that, where we're given a point, x and a y, so x equals a, y equals d, and then we're asked to find y when x equals a particular value b. So first thing, we've done that, we're going to use this condition now, y equals d when x equals a. So what that means is that y is equal to d when x equals a. So all we've done is we've just taken this equation that's got the box around it, we've substituted x equals a and y equals d into that. Now this is going to be useful because we can actually rearrange this to solve it for for c, I should say. So once we've rearranged, we've now got c equals d minus f of a, and the cool thing with this now is you can actually put this back in to your differential equation. So we end up with, or the solution to the differential equation. So we end up with y equals a function of x minus a function where a is put in, so the x value that we know, plus d, which is the y condition that we know. So the x condition we know and the y condition we know. Okay. At this point, we're kind of nearly there with where we want to be. Now, I'll just do this in a different colour. We want y when x equals b. Now that would mean that we want y when x equals b. So I've just replaced the x with a b. And what you might recognise here is that this is two integrated functions, one take away the other, with substitutions made for x. So this part here is really equal to an integral of our original little function, which was little f of x, and not only an integral but a definite integral, because you're now evaluating it between a and b. B is the first thing that we put in here or substitute in, and then we take away the second substitution, so it would be the top terminal minus the bottom terminal plus d. So that actually tells us our solution for our differential equation is given by what's here in the green box. So y is going to actually end up being a definite integral of our original function, and your CAS will be able to do this integral as a definite integral between b and a, where a is the point that you already knew and where d is the y value that you already knew. So if I just do those in like blue, this one and this one, those two conditions are known. They're given to you. Okay, b is given to you as well to help you to find y. So b is the one that helps you to find the y. Okay, so what we'll do is we'll actually use this method here for this next example. We'll do it in a standard way as well, so you can compare the two methods. So if we use our original method, which is just integrating, because we do actually know how to integrate the function that's there. Method 1, we're asked to solve the DE, which is dy dx equals x squared plus 2, given y equals 7 and x equals 1. So they're the conditions that are given. Find y when x equals 3. So in our first method, all we're going to do, write down our differential equation. We're going to integrate both sides. And because this is a pretty straightforward one, we can integrate this function pretty easily. So we get x cubed on 3 plus 2x plus c. Then we're going to use the condition that we're given, which is x equals 1, y equals 7. So we get 7 equals a third plus 2 plus c. which means that C equals, and you can go through and take away 2, 5, take away a third, which would be 15 thirds, take away 1/3. So I've just taken the 2 over to make it 5, which is 14 thirds. So then what we're going to have is y equals x cubed on 3 plus 2x plus 14 thirds. So that's used that condition. We've solved the DE, and the last part is saying find y when x equals 3. So when x equals 3, we're going to have y equals 3 cubed on 3 plus 2 times 3 plus 14 times 3. And if we do that, we'll end up with 27 on 3, which is 9, plus 6 plus 14 on 3. And if we add that up, it would be 15 plus 14 on 3. And I'll just put the solution so you can see it. So you'll end up with 59 on 3 is where you would end up. So if we were to add that all together. Now what we're going to do is use the second method and use this new formula that we can utilise if, for example, we weren't able to integrate this easily. So now we're going to use a definite integral. So now I've just opened another page here. So we're going to look at the second method of doing this problem, which is to use this formula here. So we're looking at the differential equation. This differential equation here would be our fx, our little f of x. So our answer is going to be, first of all, we're going to have to integrate x squared plus 2. The a and the b here, the a is the x that you've been given, with the y that you've been given being the d. So we're going to have the a that we've been, or the x that we've been given here, this is our a, this is our d, and this is our b. So we put a in, a is 1. The d, the plus d, that is 7. And the x that we've been given to help us find a particular y is our b. So we're going to just look at the definite integral between 3 and 1 of x squared plus 2, and we're going to add 7 to that. Now you can use your CAS for this. So I'm going to open my CAS and we're going to put in this definite integral. So we just type in integral, put in the function, which is x squared plus 2, and the terminals are 1 and 3. So x squared plus 2, and the terminals are 1 and 3. And then push enter. And what that does is it automatically puts it into your integral, puts your terminals in, and then integrates to find your answer. So that's 38 over 3. Now we know that the particular answer we're looking for would be that definite integral plus 7. So I'm going to take that answer, I'm going to add 7 to that answer, and we get 59 over 3. So going back in, we find that we get 38 over 3 plus 7, which gives you 59 over 3. And if we compare our answers, 59 over 3 was the answer that we got here using the first method and doing all of this work integrating. So in the particular case where you have a function and you're given 2 points and you need to find the integral given one other x point, you can simply use this method here of integration, okay, which is an alternative method. So you're using a definite integral to try and find the solution to your differential equation. The key thing to remember is the points that you're given, the x and the y. The x is your bottom terminal, the y will be added to your definite integral, and the other x value that you're given to find y will be your top terminal b. And then it's just a matter of substituting those values in and using your CAS to find the answer.